Hi everyone, this is Fahad Mirza and I welcome you to the channel. We are continuing our coverage of Gemma 3 model from Google, which was released few days ago, and we already have covered it in terms of full installation in different modalities. We have seen how to fine tune it on our own custom dataset, and we have seen how to do RAG and also the function calling. In this video, we are going to fine tune this Gemma 3 model to make it a reasoning model. I will be sharing with you the Google Colab notebook link too so that you could also follow along. But I will be using the free Google Colab in order to accomplish this with the help of Unsloth library, which is one of the easiest way to fine tune any model in a context format. I already have covered Unsloth a lot on the channel, so just go to my channel and search with Unsloth and you should be able to find a lot of videos around it. Now the method which we are going to use is called as GRPO. I already have also done heaps of videos on GRPO, which was made famous by DeepSeek, and we have covered it. So if you're interested in learning in more and detail and in more technical depth, please check out the channel. So what exactly we are going to do here? We are going to use GRPO technique to fine tune Gemma 3 model on a custom data set. Fine-tuning is a way to improve a pre-trained model by giving it additional training on a specific task or dataset. Instead of training a new model from scratch, you take an existing model that has already learned general knowledge from huge amounts of data and teach it to perform better on a particular task by showing it examples relevant to that task. Now, a reasoning model is a model that is developed to solve complex questions or problems through logical thinking, step-by-step analysis, and structured explanations of how it reached its answers. These reasoning models don't just provide simple answers, they are trained to clearly show how they think through solutions, making their behavior more understandable and trustworthy. So now we know what exactly we are going to do, what is reasoning model. Now let's try to do it. I'm just going to go to this Google Colab, as you can see on the screen. It's a free Google Colab, so just click on runtime and then from here just change runtime to free T4 GPU. You can also access it at colab.research.google.com and log in with your free Gmail account. First up, let's set some of the parameters in terms and configuration in terms of this Google Colab notebook. So let me first run this. Now this is going to install VLLM, and also you can see that we are installing this Hugging Face transformer which supports Gemma 3 model. So let's wait for it, and while that happens, let me also introduce you to the sponsors of the video, who are Camel AI. Camel is an open source community focused on building multi-agent infrastructure for finding the scaling laws of agents with applications in data generation, task automation, and world simulation, and I will drop the link to their website in video's description. And that's done. Let's do a bit more installations of some of the prerequisites. So I'm just installing some other stuff like bits and bytes, Hugging Face Hub, and few other things. This is going to take a minute or so. And all the prerequisites are done. Now, in order to fine tune a model, you need two things. You need a model and a data set. So let's first grab our model, and you can see that we are grabbing this Gemma 3 1 billion, and you can use the same instruction sets to use on other variants of this model when they are available. For now, only Gemma 3 1 billion is available with Unsloth. So let's wait for it to get downloaded. And the model size is just around 2 gig, so it shouldn't take too long. And that is almost done. There you go. And it is also downloading the tokenizer. And that's all done. Next up, we need to apply the low rank adaptation, or LoRA. So what is happening in this code here is that we are applying this low rank adaptation that allows a fine tuning of only a small subset of parameters, and these parameters are in the attention layer and the MLP layer in the model, and that primarily enables us to have lower memory requirement and quicker fine tuning. And that is all done. So our model is ready. So second thing we need is dataset. So let me download the dataset, and here we are going to use this OpenAI's GSM 8K dataset, but of course you can use your own dataset. It's a very small, very I would say famous dataset. So let's wait for it to get downloaded, and that is also done. And then the Unsloth team has just done some data massaging, where they are just extracting these hashes, because they are scattered throughout responses, just to make sure that the data is good formed. Okay, so that is done. Next up, we need to create a system prompt. So this system prompt is quite interesting. So here, the system prompt is a customized one, and they have added 4 extra symbols for working out or thinking reasoning sections, and also a final answer. And it is very self-explanatory, as you can see these tags. And you can also then map the data set with this one. So let me show you what I mean. Let me first put the code in, and I will also just display one item from the data set. So this is where the mapping is happening with the system prompt and the extracted hash answer. So let's run this. There you go. So this is how our data set looks now. This is a question, this is the answer, this is a system prompt with those tags which we defined above, and this is the final answer. Okay, now we have our data set. We also have to define a regular expression or regex to match the reasoning sections and answers. And this is where again we are making sure that our data set is good formed and the results are what we expect. If you want to, then we want to create a reward function to match the format exactly. And you can define whatever reward you want to do, but for instance, in this reward function, we are just giving it score of 3 if it is successful. So in very simple words, at high level, the way these reinforcement learning or reasoning models work is that if they get the right answer, they get rewarded, and that is how they learn. If not, they go back and do the answer again. And as I said, in this reward function, we are rewarding the model with 3 points if it succeeds. And if it fails, we want to reward the model if it at least follows the format partially by counting each symbol. So for that, you can define another function for partial or approximate matching. This one was exact match, this was approximate match. And finally, then we are extracting the generated answer and rewarding, so that we could reward or penalize it. Again, let me paste the code here. So this is a code. So we are just checking the answer. This is extracted response after a model generates the answer. And then this is in the loop. We are giving it the score by calling the above function which we have just defined. So I think I needed to do it here. So I'll just add another and paste it here. There you go. So we have just defined the function now. Also, sometimes what happens is on the edge cases that it might not be one number as the answer, but like a sentence, for example, it says the solution is $30 and we just extract the 30. So primarily, we also want to match the numbers, and that is a function we are defining. And that will vary from your own dataset to dataset. And that is where, in my opinion, you should be using any coding model like Claude or OpenAI to make sure that you define these functions through them. Okay, so that is done. Next up, what we can do, we can again do the number checking function. So this is just a number checking which I explained above. And then once this is all done, we can define our training arguments. For training arguments, let me first paste it here. So these are the training arguments. Now I have done heaps of videos on these training arguments. If you are interested, you can learn more about them in my channel. Just search with them. So for example, we are defining here the learning rate, optimizer, gradient accumulation. So let me run this and I will explain more on these parameters. So in order to start the training, all you need to do is just use this Hugging Face GRPO trainer with all these parameters, specify your model, specify your tokenizer and the data set, and off you go. And we will also give it the reward function because that is how this GRPO works. So let me run this and then I will explain in simple words what exactly these parameters mean. So the training has started. It is going to take considerable time. While it runs, I'm just going to walk you through these parameters because I believe it is imperative to learn them. So here you can see that we have this max prompt length, which is 256 or something. So this sets the maximum number of tokens. Token could be a word, it could be a punctuation, even a letter. And so maximum number of tokens allowed in the question or prompt is what max prompt length is. And then we are importing this TRL library, and then we are getting this GRPO trainer. After that, these are the training arguments. So there is a learning rate. Learning rate determines, I'll go from here, learning rate determines how quickly the model learns from new data during training. And here it is set to very small value just for the demo purpose. Then we have this Adam beta 1. This is a parameter that controls how much the model adjusts based on past gradients or momentum of the model, and it is set to 0.9 here. And then we have Adam beta 2, which is a parameter that controls how the model adjusts based on the previous scaled gradient, and that primarily only stabilizes the training. Then we have weight decay. This encourages smaller and simpler values for model parameters to avoid overfitting so that model doesn't start memorizing or cramming. Then we have warm-up ratio set to 0.1. This ratio slowly increases or warms up the learning rate at the start of training for 10% of the total steps of stable improvement. And then we have LR scheduler type as cosine that specifies that the learning rate should gradually decrease following a cosine shaped curve as the training continues. Optimizer is Adam W torch focus. So this selects Adam W, which is a very efficient stable optimizer specifically designed for training models very quickly, and this is what normally is used. Then we are logging the steps at 1. So this primarily shows or logs training information or progress after every training step. So after first step we are logging it. And then we are defining this per device train batch size. That is a number of training examples processed at one time on each GPU device. So we only have one, of course. And then gradient accumulation steps are simply 1. So this lets you accumulate or add together gradients over multiple batches before making an update. And this is really for memory optimization. Number of generations are 4. So this generates 4 possible answers for each prompt, and then it enables it to pick and learn from the best one. And then we are just giving it max prompt length, which we already defined above. Max completion length, again that limits the length allowed for model's answer. And then max steps are 50. So this is the maximum number of steps we'll run the training loop for. It's very short just for the demo purposes. I was actually quite tempted to do for 10, but anyway. And then we are just saving it at the end. The models are checkpoints. And then the max grad norm is 0.1. That limits or clips the gradient values so that they don't become too large. And we are not reporting, and we are just storing it in our outputs directory. So if I go back, you can see that training has started, and it will soon going to give us what it is doing, which you can see how a model is going. All the reward stuff is happening. While the training is proceeding, let me also explain this output a bit, especially this one where it is showing us the steps. So here step of course indicates the current training step. We have 50 of them, and then it is talking about training loss. This measures how well the model is learning. A lower number generally means the model predictions are closer to correct answers. And then we have reward. This is a total reward score. Remember we said we will give it 3 if it succeeds, which is not the case at the moment. And so then we have reward STD or reward standard deviation. This shows how much individual reward scores vary. A small value means the performance is consistent across tasks, while higher number shows more variability. And then we have completion length. that measures the average length in tokens of the responses generated by the model during training. And then we have KL divergence, this one. This primarily indicates how much the current model predictions differ from the original model predictions. Higher KL means the model has changed a lot during training. And then we have this rewards. That score measures how often the responses match exactly the template format provided for reasoning and solutions. And then we have reward responses if a response contain approximately correct formatting token, even if not perfectly structured. And then we have this reward check answer, that rewards based on checking whether the generated answer match or are close to the correct numerical answer. And finally we have this reward check numbers, and so additional reward for correctly extracting the numerical solution clearly from the response and matching it exactly to the numerical answer. So all in short, these columns summarize how well the training is progressing overall, indicating quality of generated reasoning, correctness of answers, clarity, which is formatting of course, and consistency of learning progress. And you can see that it is progressing quite well at the moment. So I'll just scroll down. These are all the answers and stuff. I will let it run for a bit because this is going to take, considerable amount of time. And if you go up, it also shows you a bit of an ETA. So it is currently telling me around 42 minutes. So 6 have already been passed. So around 50 minutes or even hour, it could fluctuate. And the model has been trained. As you can see that all the steps are done and loss has considerably came down. And then it is also giving you some other log. Next up, either you can save the model locally or you could push it to Hugging Face. So this saves the model with this name locally in your current working directory or the output directory. And then this is where you can push it to Hugging Face Hub. All you need to do is to just grab a write token, which is a free token from your profile in huggingface.co, and then put it in there. So let me save it locally. And that's done. So model is saved with its tokenizer and other metadata. And in order to do the inference with your brand new reasoning model, which is Gemma 3, you can just give it this prompt template. You can apply that prompt template, and we're asking it what is the square root of 101, and there from here you're just calling your own new model here, and then this is the hyperparameters which they recommend, and then just stream the response. So let me run it. So you see it has started the reasoning process as it runs. This is a beginning of sentence. There you go. So it is understanding the problem, thinking, and then it has given us the answer. You can similarly ask it any other question like what is the capital of Fiji, and then just run it. Let's wait for it. There you go. So it is working out. It is understanding. It says capital of Fiji is Suva. So the more complex problem, the more thinking it is going to do. Now don't expect it to be a very hi-fi model, by the way. We just did a very minimal training on a very minimal data set for a very short period of time. 40-50 minutes is nothing for the training. And then it's a context format model, but you already saw that Hugging Face GRPO trainer and this Unsloth makes it really easy to create a reasoning model for free on just free Google Colab. So really good stuff by Hugging Face and this Unsloth. Let me know what do you think about this. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.